mathematicians. In this video, we're going to look at how to create the equation for a tangent line. So the first thing we have to remember is the equation of a line. So there's two forms, point-slope form, which is y minus y1 equals m times x minus x1, or there's slope-intercept form, y equals mx plus b. Remember, this m represents the slope. And in calculus, the slope, the rate of change, is the derivative. So let's do an example. Determine the equation of the tangent line of g of t equals t to the 4 at t equals 2. The first thing we need to find is our slope. To find our slope, we need to take the derivative. So here's my g of t function. Let me find g prime of t. Well, here I just have the power rule. T to the 4, I'm going to bring down that exponent, 4t, and subtract 1. 4 minus 1 is 3. Now I'm going to find g prime of t when t equals 2. So I'm going to plug in 2 into my derivative. So once I plug in 2, I get 4 times 2 to the 3. 2 to the 3 means 2 times 2 times 2, which is 8. 8 times 4 is 32. So now this is going to be my m in my equation. You can use whichever one you want, but no matter which one you use, in order to find the b, or to find the rest of the values, you need to have an x and a y value. So here this t equals 2 is our x value, but we need to find our y value. To do that, I'm going to plug in this 2 into g of t. So I'm going to rewrite g of t equals t to the 4, and g of 2 is 2 to the 4, which is 16. So now I have my x1, y1, and my slope. I can just plug it into my point-slope form. So let me just move this over a bit. I have y minus y1 is 16 equals m. Remember, m is the derivative evaluated at a point. So m is 32. Parentheses x minus x1, which is this 2. So I could just leave it like this. Some people prefer to use the slope-intercept form, and let's walk through that as well. So this is one correct answer, but if you want to use the other form, you're still going to use your values that you found. So you're going to do 16 equals m is 32, x is 2 plus b. And then you would solve for b. So if we multiply, we get 16 equals 64 plus b, and subtracting 64 on both sides, you get negative 48 equals b. And in the last video, I saw a lot of people made a mistake with that. Now we have to rewrite the equation using our x and y. Slope is 32, put in your x, and then the b. So both of these are correct answers. Choose whichever way you find easier. I think this way, there's a little bit less arithmetic you need to do, but both ways are correct. Let's do another example. Given the function f of x defined below, state the equation of the tangent line at x equals 1 and use it to approximate f of 1.1. So here's our function, and we still want to find the tangent line. That's still our goal. So the first thing I'm going to do is I'm going to find my slope. However, this is a pretty messy function. Before I find the slope, I need to rewrite this function so that I can take the derivative. So let me write f of x equals, I'm going to pull my fraction out to the front, 3 over 2 x squared, minus Remember, we always take our power over our root. So this is x to the 1/2 plus, pull my fraction out again. Now, if I have something in the denominator, I want to bring it to the top by changing the sign of the exponent. Minus 2.9x plus 5. Notice, again, I'm not taking the derivative. I just rewrote the function. So I need to write f of x here. Now that I've rewritten it, I can find f prime of x. So I'm going to take my exponent, put it in the front. So that gives me 2 multiply 3 over 2x, and 2 minus 1 is 1. And then again, I'm going to take my exponent, put it in the front. So minus 1/2 x. And if I do 1/2 minus 1, 1 is the same as 2 divided by 2. So that's going to give me, the denominator stays the same. 1 minus 2 is -1. It's -1/2 plus 2 over 5. I'm just going to leave it in the front. Multiply by my exponent times -4x. And remember, when I subtract 1 from a negative number, it becomes even more negative. And here I just have x, so my derivative is the coefficient, and the derivative of any constant is 0. So now I have f prime of x. I can find the value of the derivative at x equals 1. So I'm going to simplify that a little bit. So I get 3 times 1 minus 1/2 times 1 to the -1/2 plus, let me simplify this, 2 multiplying -4 is -8 over 5, plugging in my 1 here, to the -5 minus 2.9. And really, I could have put in my calculator much earlier on. Let me actually do that so I don't make any mistakes. I'm going to go to y equals 3x minus alpha y equals, let me put it in as a fraction so I'm not making any mistakes. 1 divide 2x exponent -1/2. Move out of the exponent, plus 2 divide 5, parentheses -4, x exponent -5 minus 2.9. So now this is in. I can press graph, and if I press trace and I put in 1, enter, oh, that evaluates to -2. This equals -2. So now I have my slope, I have my m. I need to find another point. Well, I can put that in my calculator as well. So let me put the original function in the calculator. So then let me press graph and trace, and I want x equals 1. Oh, that gave me my derivative graph again. So let me just go up, 1, enter again. So I get y equals 3. So let me write that down. F of 1 gave us 3. I used my calculator. So now all we have to do is plug it into our point slope form. So I have y minus, here's my y value, 3, equals my slope, which I have over here, -2, parentheses, x minus, and my x value here is 1. So now I've found this equation of my tangent line. I can use it to approximate f of 1.1. So this 1.1 is my new x value. 1.1 is going in for x. So I have y minus 3 equals -2 times 1.1 minus 1. So I get y minus 3 equals 1.1 minus 1 is 0.1 times -2, -0.2. And then I add my 3 on both sides, get y equals 2.8. So that tells me that f of 1.1 is approximately 2.8. And if I check that in my calculator, if I put in 1.1 in my trace, I get it's 2.849. So it's very close to this value. So this allows us to approximate. And when we're doing a lot of calculations, you might want the approximate answer, which would get it to you faster than the actual function, which might take much longer for a computer to solve. So the key things to remember are your equations of your lines, and that m is your slope, which is in calculus the derivative. Let me know if you have questions.